Timeless concepts from physics applied. In this video tutorial, we will discuss a multiple choice question taken from JEE Main exam of 2023. The question is based on the magnetic field produced by a circular coil carrying current. Read the question carefully. A long conducting wire having a current I flowing through it is bent into a circular coil of n turns. Then it is bent into a circular coil of small n turns. The magnetic field is calculated at the center of the coils in both cases. The ratio of magnetic field in the first case to that of the second case is. The options are given in the question. We are required to find the correct option. Now for the solution. Now let the length of the conducting wire is equal to L. Therefore we write length is equal to L. Now first, in the first case, the conducting wire is converted into a circular coil of capital N turns. Let the radius of the circular coil in the first case is equal to R1. Therefore, in the first case, length of the conducting wire L should be equal to 2 pi R1 into N. 2 pi R1 is the length of the circumference of the circular loop, that is 2 pi R1. R1 is the radius, and into the number of turns is equal to N. Therefore, L is equal to 2 pi R1 into N. From this, we get R1 is equal to L divided by 2 pi into N. Similarly, in the second case, let the radius of the loop is equal to R2. Then this should be equal to L divided by 2 pi into small n, because small n is the number of turns in the second case. Therefore, the magnetic field at the center of both the coils, in the coil in both the cases, for that we will be using the formula B is equal to mu 0 Ni by 2R, where N is the number of turns and I is the current through it and R is the radius. Therefore, in the first case, the magnetic field produced at the center of the coil of capital N turns can be written as B1 is equal to mu 0 Ni by 2R1. Therefore, putting the value of R1, we get mu 0 Ni divided by 2 into R1. For R1, we write L by 2 pi N, capital N. L divided by 2 pi, capital N. Now 2 gets cancelled, and on simplification, let us simplify this. Now pi N divided in the denominator becomes, we multiply pi N in the numerator, which gives mu 0 into pi N is already there, therefore pi N square into I divided by L. Similarly, the magnetic field produced at the center of the second coil is given by B2 is equal to, we'll write like that only, mu 0 pi capital N square becomes small n square, I is also common, and length, total length is also L. So B2 is equal to mu 0 pi n square, small n square, I divided by L. Now let us find the ratio B1 by B2. Now mu 0 pi I in B1 and mu 0 pi I in B2, they are common, and also divided by L is also common. So this gives us simply n square divided by small n square. Now this is the answer to the question. Therefore, the correct option is B1 is to B2 is equal to n square is to n square. This is the answer to the question. Therefore, the correct option is 3. 3 is the correct option. N square is to n square. So 3 is the correct option. This completes the answer to the question. Thanks for watching.